All right, I'm Xander. I do Python for fun. I've given a few talks here before. I was looking at job recs recently myself, looking at software jobs, and it came up a lot of times. CI/CD experience was useful, so thought it'd be good to gain a little bit of experience in this area. And some of it comes from testing forward and automation. It's an interesting area for me to have a good test suite and have a nice automated pipeline. It seems like an advanced way of working. So that's the point of giving this talk, get some experience in CI/CD pipelines. I highly recommend giving talks at Mission Python. It gives you that extra oomph to go try something new and that accountability to go talk in front of other people. So highly recommend giving talks. And again, the community is great. So if you have questions, feel free to reach out to one of us on Discord. We're happy to help. And so this talk is based on a DataCamp tutorial. So there's a link in the presentation. So this is not my work at all, but I just put it together and happy to chat about it quickly for 3 more minutes. So what is the CI/CD pipeline? The whole point of a CI/CD pipeline is continuous integration, continuous deployment. So you have your code, you make changes. In this case, machine learning model, you have data as well. So you have code, you have data, you put it together in a local repository, you push it to the remote server of GitHub, and then you have these GitHub Actions do this continuous integration, continuous deployment of your code. And so the first part in machine learning example, it could be any type of code, it's just a machine learning example, classifier tree. So on the one hand, you've got this push to main. On push to main, you do this integration of the software, which is in machine learning, you train your model, you create your model, you deploy your model, you evaluate the model on your data. And so that's the first step. That's your integration of the software. In like the automotive space, this could be a lot of different features being compiled into a subsystem, being compiled into a system and releasing it that way. So that would be a different way of integrating or what you want to do for integration. So there's interfaces between those different features that need to work. And so that's what you want to be doing in testing specifically with this integration. You want to compile the code, make sure it compiles, make sure that the features work together and that you didn't change something inadvertently as you updated a feature. So that's the integration side. And then the other side of it is once you've integrated your software, the other side of it is to do the deployment. So you've got, in this case, machine learning model, it's going to get deployed to Hugging Face, which is a machine learning model repository online. And so this takes this model and sends it and makes the web applet on Hugging Face so that it can be accessed. So that's the deployment side. Like, hey, we've made this model. Now we're going to deploy it as software to a weblet online. So that's continuous integration, continuous deployment. Why do continuous integration, continuous deployment? Well, first off, we're coders, and so we're lazy. And so we want to have all this work once we've made a change done for us. We want all this integration to be done for us automatically. And then we also want the deployment done automatically. So that's the first step, is that this is an automated pipeline of software development. And so that gives you this development side of building, merging, you plan your code, you branch it, you code, you merge it back into the main line, then you build the software, then you release it, deploy it, operate it, people use it, and then you monitor the usage. And so with this continuous deployment, continuous integration, continuous deployment, you have places to test automatically throughout the loop, so you ensure quality. And you have reusability of a lot of different functions to get the integration to work. So that's the motivation behind doing CI/CD. And so quickly, I'll show you what I did. So the GitHub Action, this is integrated into GitHub. So if you go to GitHub, there's this tab for Actions on the top. And so you create a new workflow, you have your continuous deployment, continuous integration. And so these are just scripts integrated into GitHub. And then you specify YAML files for this, in this case, CI.YAML. You call it continuous integration, it says on, so this is your trigger when you push to the main branch, so that when that GitHub command occurs, you give it write all permission, you use Ubuntu, this is this checkout, and setup are, again, reuse of code. So this allows you to use integration automatically. You install the packages that are needed to run your Python code automatically. This is specified in a recreation file, in the make file. So you, again, automatically do all those things like install packages, format, train the model, evaluate the model. You have this token of like the GitHub token to give you access to GitHub. Then you update the branch, and then you specify username, user email, because this will send out a report to your email, for instance. So that's the integration side. And then the deployment side is very similar, where you specify when it runs, when the continuous integration is completed, you'll run the deployment. This Ubuntu latest, which kind of server you're going to use, the checkout, and then this deployment to Hugging Face. Deploy it to Hugging Face, which is again a website where you can host online the weblet. And then these are calling this make file. And so here's where all these things are specified. If here's your install, so it's calling this requirements file. Here's all your packages, here's your formatting, your training, and then your evaluation of your model. So again, you're getting testing, you're getting reports out, you're making changes to your code, and you're getting results. And then we're updating the branch, and then we're logging into Hugging Face. So you automate all these credential things can be a pain. They were a pain for me. But again, you automate this, you store all this data so that when you need to deploy it, just automatically logs in for you, which is great. And then here's the website, the weblet that it made. So anyways, that's the deployment, that's the make file. And here's the requirements, here's all the packages. So you just make your list of packages that you need to install to run your software, and it does that for you. So that's the gist of it in GitHub. And then I'll just show real quick the commands to actually run, just to show you that it works. So I'll go to Visual Studio. So Visual Studio Code is very good for this because this is new to me, but it has Git integration. So this shows you all the commits, the order of all the commits. So that helps you keep track of your software provenance. And then, for instance, here's the CI/CD, the GitHub Actions, but the CI/CD pipeline. It shows you how it did. So here's failing and then passing the integration, then failing and then passing the deployment. So you can keep track of your integration deployment, whether your pushes actually worked. And so we'll make a change. This is just the random state of the model. We'll change it from random state 124 to 125. We'll Control S, save the file. We'll check our status. We'll see that we modified this train.py file, which we just did. And then once we do that, we'll do a git add git add all files, and then we'll commit, and we'll change our commit message to 125. We change the random state. So now we committed the change, and now we're going to push the change to the remote. And now once this happens, give it a few seconds, but then we'll see the continuous deployment or continuous integration kick off first automatically. And then we'll get results back from the model, so we know how it did with this change. And then the deployment will send up to Hugging Face. Any questions while this is running in the background? It takes about a minute to run. So I'll cheat. I did run this earlier, but couldn't agree more. Okay. Thank you, Brandon. Here's the weblet. So this is all this all got deployed automatically. I mean, it was coded, but this all gets deployed automatically. So you've got a website that's publicly available that allows you to. There's a drug classification of given these inputs of the age, the sex of the patient, and then what the blood pressure is, their cholesterol level, and then a sodium to potassium ratio. You can submit it, and then it outputs a predicted drug match based on the classification tree. So it's again pretty cool to have something be deployed for you automatically and on the web. Let's check and see if the CI/CD ran. Actions. Okay, so here's, yeah, so it did just work. So here's the integration. 1 minute ago, it took 49 seconds to do the integration. And now sends me an email. All right, just for instance. But yeah, it sends you an email of the results, which in the case of machine learning is to tell you the accuracy and the F1 score, and then a confusion matrix. Let's go back to the presentation real quick. So here's the email to me from GitHub showing the model metrics, so the accuracy of 0.98, and then the F1 score, which is just how good the machine learning model is. And then here's the plot of the true label, what the actual label was, of their Y, and then here's a predicted label. So anything along this axis is good. This is correct. This is matching the true, the predicted matches the true. So it's just nice to have that feedback. I mean, this feedback can be whatever test you want it to be, but so anyways, it will automatically send you the results, and then in the comments in GitHub as well have this report of how the integration went. So any questions? Awesome. All right. Yeah. Thank you.
Question.
Yeah.
You using machine learning as an example, how resource intensive is that, since GitHub Actions has like a free tier?
It works. That's, it works for free. I'm sorry, I can't say, like, I don't have a resource, I maybe there's a monitor I don't know of. I don't know how much resources it's taking. This is a classification tree, it's very lightweight.
Okay.
I'd say it's fairly lightweight. But yeah, both on the Hugging Face side and the GitHub, it is running for free. So
Okay.
that's, you can get away with it basically. But yeah, there is some, I think the data set is minuscule as well. It's a few kilobytes, and I think it's like 50 rows maybe, so it's not a ton of data. So
That's right. I've seen companies run into limits when they try to do it, I'm too big.
yeah, so yeah, definitely machine learning. You always want to have a sense of how big your data set is, how complete your model is, and all that good stuff. You want to keep that in mind.
But we're able to get meaningful test feedback
Right.
without hitting a limit.
Yeah, so
Nice.
this is what you'd want to know, irrespective of how big your model and data set is. So it is able to, and if you're doing something big time, like a large language model, which I think they're like measured in gigabytes or bigger. It's like how big the llama model. I think in Hugging Face, I was reading about Hugging Face, but it's like how big. It's like how much memory do you have available on your computer, as far as like how many gigs of memory do you want this large language model to be? Like how big do you want? But then you download too big of a model, whole problem. So
you could just do like PyTest or like talk suites in there as well, right?
yeah, add whatever you want. Again, it's just scripting.
Yeah.
Essentially, so you can add in like scikit-learn has an eval function, and we're just calling the eval function and writing that output to that file.